Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. If you look at student, this is actually a lactone. Lactone means cyclic ester or intramolecular ester. Okay, so by nature it is actually a ester molecule, and there are three sets of reaction, so it is actually multi-step reaction. So in this case student, I prefer, let's go it stepwise. So let's go. Now if you say lactone, can I say that these two oxygen attached to this carbon, so it is delta plus, and these two oxygens are delta minus? Can I say like that? Yes. Now if you look at HCl molecule, HCl is student actually a polar covalent molecule. It is by nature, it's a gas. So this is delta negative, this hydrogen is delta positive. So you may think like that, this positive negative will react together and these hydrogen will be abstracted. Now how you can think that, okay, this H plus will be attached here to make OH plus. After that this remaining Cl minus will attack there. So it will be open up, again it will come back and it will leave. So what is the product here? Student, when you open a ring, write everything as it is. This is O minus. This is here double bond OH, oxygen carrying a positive charge. And obviously here Cl. I can do one thing that, okay, this is delta plus, so let's attach chlorine here. This is delta minus, let's attach hydrogen here. Answer is right, but that is not more logical. So because if I say this is your ester, double bond OR, I'm not showing other part, so it can have a resonance. Resonance means this lone pair can come here, it can open. So another canonical form, this is oxygen double bond with this carbon, it is O minus this. So from, and this is carrying plus. So if you take a weighted average of these two canonical forms, you can conclude that these oxygen have more electron density. So if it has more electron density, you can say this is comparatively more basic. So who will abstract proton initially? Obviously this carbonyl oxygen of ester. Okay, now this is, now these O minus can abstract this proton and ultimately it will result the same thing. So this is OCl and this is OH. Now again, this first step, HCl's job is done. But what about SOCl2? SOCl2 can react with OH and ultimately it can produce, this OH will be replaced by again Cl after reaction with SOCl2, and obviously fate of SOCl2, SO2 plus again HCl will be regenerated here. Both are gas, so they can come out. So in this way the reaction will take place, the first step. Now if I say in first step, what is my product? Everything as it is, here Cl, here O, here acid chloride. So chloroacid chloride. By the way student, very important point, always remember, be careful about carbon count while you are opening a ring. So carbon 1, 2, 3, 4. Now you may ask one question, sir, why you have written in this way? Can you write in this way? Yes, I can write. This is 1, 2, 3, 4. But I believe next step it is better. Okay, so that's why generally I prefer to solve the problem in this way, not by this drawing. So I ignore. But if you want, you can do. It creates an unnecessary headache on mind, which I don't like. Now if you look at next step, it's actually benzene AlCl3. By the way, now acid chloride there, benzene there, AlCl3, what could be the reaction? Now you may have a confusion that, sir, here C acid chloride means sp3, this carbon, if I say this is sp3 hybridized, there is a sp3 CaCCl bond and versus there is a sp2, where the reaction will take place. Remember student, acyl chloride means this bond is far more reactive, so these will break preferentially, okay, in presence of aluminium chloride, which is acting as Lewis acid. And in this case, Friedel-Crafts acylation will take place and ultimately it will result aromatic electrolytic substitution on benzene. So this is your benzene, and next there will be a double bond O. Now again double bond is the carbon 1, so I have 4 carbon, 2, 3, 4. So student, that's why numbering is very helpful. It reduces the chance of mistake. Now next step, it is written KOH methanol. What can do? By the way, if I say KOH methanol, can I say this part is alcoholic KOH? I guess it is more familiar for you right now. It's alcoholic KOH, and alcoholic KOH results elimination reaction. So in this case, what can happen? Now you can say, sir, elimination reaction possible. So okay, beta hydrogen elimination. Yes, these hydrogen and this Cl you remove. But that has a problem. Then there is another option. If you look at this proton, this is actually alpha 2 carbonyl. So alpha proton, carbonyl carbons alpha proton is significantly acidic because the conjugate base, if I say, means if you remove this hydrogen and produces a negative charge here, that is resonance stabilized with this carbonyl group. Fine. And obviously ring is also conjugated system, that's a stabilized thing. Now that's why this proton abstraction, first OH will abstract proton from here and ultimately O minus, and these can attack there and it can leave. And what it will result? It will result a 3-member ring formation. So this is nothing but a cyclopropane derivative formation. So this is a product. Now you may have a question that, sir, it is a 3-member ring and 3-member ring has ring strain. Since the 3-member ring has ring strain, why does it form? Here very important answer, 3-member ring forms easily because of having proper conformational orientation. What does it mean? See student, for any chemical reaction, the reacting center should collide properly. What is mean by the word properly? With proper conformational orientation, then only bond formation possible. And in case of 3-member ring, although I agree that there is ring strain, but this conformational orientation could be attained very easily, and that is the concept here. So here it will be a benzene, double bond O, another thing cyclopropane ring. So these will be the answer here. Okay, so what is the major product of this reaction? Benzene attached to carbonyl with a 3-member ring. So this is the option. Now, if you do not know the right answer, how can you get the right answer? Student, actually I can give you a trick. Here I personally recommend draw the structure after each step on pen and paper. If you do this thing quickly, that will save your time, but do not try to get everything in one step. If you can do very good, I appreciate, but difficult. In this case, I suggest you to go step by step. What is the product in HClSO2? Write it. After that, benzene LC, write it. KOH methanol, write it. Then what is the product? But one tricks I can say. So if I say here actually 4 carbon, this is a C4 and this is a benzene. Leave it. Benzene means, or if it reacts, it will be pH. So PHC4 and KOH methanol, it's a base. So PHC4 means phenyl as well as carbon 4. If you look at phenyl as it is 1, 2, here 3, 5. So carbon number doesn't balance, leave. If you look at here, this balance, this is also 4, yes, it balance. So option A could be eliminated this way. Now if you think, sir, what about others? Now in this case, I suggest student go stepwise. Mechanism I have already explained why. Because aromatic electrophilic substitution, acylation is preferred because acyl chloride is more reactive. From that perspective, phenyl should be attached with carbonyl group. Option B is gone. Option A is also gone from that perspective. What is remaining? This versus this. So this is produced because of proper conformational orientation. So this is the overall discussion. I believe it's a very interesting MCQ and you have learned a lot. So thanks for watching. See you in my next video. Bye bye.